Well, we finally made it. This is your last video for Geometry B. Congruent and similar solids. The first thing we need to do before we move on to congruent and similar solid calculations, we need to understand what they are. Well, similar solids, as a simple definition, means they have the same shape but a different size. Think of going to a photocopier and hitting the enlarge button and be able to create it larger, or hitting the shrink button and make it smaller. While the math definition would be that the corresponding faces are similar, meaning they have a similarity ratio, and the corresponding angles are all congruent. Well, let's look at some similar shapes. Here we have a couple of cubes that are similar. You're told that in the instructions, and we just want to find the ratio of the corresponding sides. Well, to do that ratio, we just need to pick two sides that are corresponding, so two matching sides. Well, in this shape, it just happens that you're given the base on the left triangle is 8 centimeters, and the base on the right triangle is 12 centimeters. So we're just going to create a ratio. I'm going to put the small over the large, but you could do the exact same thing by doing the large over the small. We have 8 over 12, which reduces down by dividing them both by 4 to 2/3. Our ratio is 2/3, which means if I multiply any dimension on the large cube by 2/3, I'll get the small cube. And if I multiply the small cube dimensions by 3/2, I would get the large cube. But that's just for the side lengths. Remember, the angles will be the same no matter where you measure them. Next, we want to talk about their surface areas. So their surface areas then will be done somewhat the same way, except for we have to actually calculate them out for all of the faces, but they're all the same. To get the area of the blue square, I would just do 12 squared, which is 144. That gives me the area of the blue. The nice thing is we have 6 faces that are exactly the same, which gives us 864 times 6. In the small cube, its faces area is 8 squared, which would give me 64 times 6. Again, there's 6 faces on there. So when we take 64 times 6, we get 384. So our surface areas then are 384 over 864. The ratio of the corresponding surfaces then, all we do for that is we reduce down that fraction that we just created. Now, using your calculator, you actually can plug that in and get 4/9. If you don't know how to do that on your calculator, stop in and ask me, or you can just simply do it the longhand way, which is divide by 2's, divide by 4's, divide by 3's, until you eventually get down to 4/9. It's kind of a painful exercise, so I would definitely come and see how to do this on your calculators. There we have our ratio of corresponding surfaces, or surface areas. Next we have the volumes. Well, we do the volumes just like we always have, but the nice thing is, since the squares, or the cube's dimensions are 12 by 12 by 12, we just simply do 12 cubed. 12 cubed would give us 1728 for the volume of the large cube. Then we go on and do the exact same calculation for the small cube, which would be 8 by 8 by 8, which would give us 512. So now we have our 2 volumes, and all we need to do from there is reduce them down to lowest terms. Again, this is really simple to do on your calculator, but if you don't do that, go ahead and do it longhand. Reducing that fraction down, we get 8 over 27. And we're done. So let's look at this from a bigger perspective of having all of these all in one page. So as we look at these just from one page here, ratios of surface area and volume. Well, let's start with, what was the scale factor? It was simply 2 to 3. Now to get the area surface area, we calculated that out to be 4 to 9. Let's just look at those two to start with. Well, how do you get from 2 to 4? Well, multiply by 2 is one way, but let's think of a more math way. Area is when we multiply two dimensions. So if we take 2/3 times 2/3, you're going to notice we get 4/9. But instead of doing 2/3 times 2/3, how about if we do 2 squared and 3 squared? As you think about area, you can think of that, as you look at the label, it is a squared dimension. It is a two-dimensional calculation. So to get to surface area, we're going to square the answer. As we go to volume now, if you look at this, volume, as we think of the label, is a three-dimensional calculation. You're taking length times width times height many of the times. So volume is always cubic. Well, if I go back to the beginning and I cube 2 and cube 3, you're going to notice I'll get 8 and 27. That's how we're going to use this. So we're going to set up some formulas. If scale factor is a to b, then the surface area would be a squared to b squared, and the volume would be a cubed b cubed. So all of that, you'll notice, is based on surface area. So if you're given a different dimension, you're always going to want to go back to surface area before you find a different one. If you give me surface area, I want to go back to scale factor. Then from scale factor, I can easily go to volume. If you give me volume, I'm going to go back to scale factor, and then I'm going to square that to get the surface area. When you get to these types of problems, if you have questions, just stop in and I'll help you. Congratulations, you've made it through all of the geometry videos. Good luck, and hope you enjoyed.